Good morning, here. Beyond this, here is the breaking news. Yes, anxiety-related disorders can have a profound impact on the mental health and quality of life of affected individuals. Understanding the neural circuits and molecular mechanisms that trigger anxiety can aid in the development of effective targeted pharmacological treatments. Delta opioid receptors, that is called DOP, which localize in the regions of the brain associated with emotional regulation, play a key role in the development of anxiety. Several studies have demonstrated the therapeutic efforts of DOP agonist, synthetic, that means the synthetic compounds that selectively bind to DOPs and mimic the effect of natural binding compound in a wide range of behavioral disorder. One such selective DOP agonist, KNT127, has been shown to exert anxiolytic or anxiety reducing effects in animal models with minimal side effects. However, its mechanism of action is not clearly understood, thereby limiting its widespread clinical application. To bridge the gap, to bridge this gap also, Professor Akiyoshi Satohi along with Miss Ayoka and team from the Tokyo University of Science, Japan conducted a series of experiments and behavioral studies in mice. Explaining the rationale behind their work, Professor Satoho says there are currently no therapeutic drugs mediated by delta opioid receptors. DOPs likely exert antidepressant and anti-anxiety effects through a mechanism of action different from that of existing psychotropic drugs. DOP agonists may therefore be useful for treatment resistance and intractable mental illness which do not respond to existing treatment. The neuronal network projecting from the prelimbic cortex of the brain to the basolateral nucleus of the amygdala, that is called BL region, has been implicated in the development of depression and anxiety-like symptoms. The research team has previously shown that KNT127 inhibits the release of glutamate, a key neurotransmitter in the PL region. Based on this, they hypothesized that DOP activation by KNT127 suppresses glutamatergic transmission and attenuates PLA. BLA meditate anxiety-like behavior. To test this hypothesis, they developed an optogenetic mouse model wherein they implanted a light responsive chip in the PLA-BLA region of mice and activated the neural circuit using light simulation. Further, they went on to assess the role of PLA-BLA activation on innate and conditioned anxiety-like behavior. They used the elevated plus match test, which consists of two open arms and also two closed arms on opposite sides of a central open field to assess behavioral anxiety in the mice. Notably, mice with PLBLA activation spend lesser time in the central region and open arms of the match compared to controls which was consistent with innate anxiety-like behavior. Bravo! Beyond this report.